This is the prerequisite review for section 2.5, applications of linear equations and modeling. And in this, on this worksheet, we are going to talk about the slope-intercept form of a linear equation. We're actually going to write an equation of a line using slope-intercept form. We're going to talk about the slope. And then we're going to write a model given a fixed value and a rate of change. So let's go ahead and begin with objective 1, slope-intercept form of a linear equation. And the slope-intercept form is y equals mx plus b. And in this form, we have m as the slope and we have b as the y-intercept. Okay, so let's go ahead and look at number 1. The slope is 6, and we have a point of 1, -2. Now, there's a couple ways that we can do this, but I think we should go ahead and jump right to the point slope form of an equation of line, and that is y minus y1 equals the slope x minus x1. So that's the point slope form, and this is the slope-intercept form. So if we start with this form and then we go to this form, we will be able to write the equation in slope-intercept form. So let's go ahead and do that. So this is y minus the y value equals the slope x minus the x value. And here we have y plus 2 equals 6x minus 6. We will subtract 2, and we have y equals 6x minus 8. Okay, let's go ahead and look at number 2. Here, the slope is 10, and the y-intercept is 0, -19. So you could go ahead and write the point slope form and then go into the slope-intercept form. However, they gave us the slope, and they also gave us the y-intercept. So with this, we want to jump right in to our slope-intercept form, and we have y equals 10x minus 19. So if we're given an intercept, we might as well go ahead and use that. Okay, let's look at number 3. Here we have a point for -3 and a slope of -4. We will begin with the point slope form. And we have y minus the y value equals the slope x minus the x value. We'll go ahead and distribute that -4. And then we will add 3 to both sides. And we come up with y is equal to -4x plus 19. Let's see if I did that correctly. Plus 16. I should have subtracted 3. It looked a little funny. And 16 minus 3 will give us 13. Okay, let's go ahead and look at number 4. Again, we have a point and a slope. We will use our point slope form and end up with our slope-intercept form. Begin with our point slope and end up with our slope-intercept form. So, for our point slope, we have y minus the y value equals the slope x minus the x value. So we have y minus a negative 5 equals 1/2 x minus a negative 4. Let's go ahead and clear those up. Minus a minus, of course, is a plus. And half of 4 is 2. And now we'll subtract 5 from both sides. And we have y equals 1/2 x minus 3. Okay. And here we end up with our slope-intercept form. Okay. Now you can look at all of these equations, and all of these are written in standard form, and it's okay. All we have to do for every one of these is solve for y. Let me go ahead and erase that. So to get into the form that we want, we will just simply have to solve for y. And that's what we do. They would like us to identify the slope and the y-intercept. So we will solve for y and then give that. Okay? So we can go ahead and subtract 8x from both sides. And we have 2y equals negative 8x plus 10. We'll go ahead and divide every term by a 2. And we have y equals negative 4x plus 5. Maybe I shouldn't circle that. Okay, so with that, they have asked us to identify the slope and the y-intercept. So all we need to do is say that the slope is negative 4 and the y-intercept is 5. Okay, looking at number 7, and we could also give this, let me do this. We could also say the intercept is at 0, 5 if we wanted. That's the point from the intercept. And we have that because of this 5 and this negative 4. Okay, let's go ahead and do the same thing here. We're going to subtract 3x from both sides. And we have 2y equals negative 3x plus 9. We'll divide every term by a 2. And we have y equals negative 3 halves x plus 9 halves. So we have our slope and our y-intercept. So with that, we have slope is negative 3 halves. The y-intercept is 9 halves. And that is at the point 0, 9 halves. Let's do the same thing for number 9. We are going to subtract 2x from both sides, and we have a negative 5y is equal to negative 2x plus 4. We'll divide every term by a negative 5. And we have y equals 2/5 x minus 4/5. So we do want to watch our negative and positive signs. So our slope is 2/5 and our y-intercept is a negative 4/5. So with that, we could say the slope is 2/5. The y-intercept is -4/5. And again, we generate that point on the y-axis, 0, -4/5. Okay, here we can jump right in. We have a slope of -2. We have a y-intercept of 3, and that intercept is at 0, 3. Jumping over to number 8, let's go ahead and subtract 3x from both sides. And we have -y equals -3x plus 5. We could divide every term by a -1, and we have y equals 3x minus 5. There's our slope, and there is our intercept. So here we have a slope of 3, a y-intercept of -5, and 0, -5 is the point that we have generated. Okay. Just move that over a bit. And let me move that just maybe not that far. Okay, let's go ahead and do the same thing. We're going to subtract 7x from both sides, and we have a -3y equals -7x minus 6. Divide by -3, and we have y equals 7/3 x, and that's a plus 2. So we have 7/3 as our slope and 2 as our y-intercept. And we have a slope of 7/3, intercept of 2, and 0, 2 is that point on the y-axis. Okay. Let's go on to applications of let's go on to slope of a line that passes through 2 points. Again, we want to keep in mind that our slope is the change in y over change in x, which is the difference of the y values, the y coordinates, divided by the difference of the x coordinates of the 2 points on that line that you are looking for the slope, okay? So I like to label these point 1 and point 2. It has always helped keep everything straight. And as you can see, I'm just running through every one of these problems, setting myself up for success. So let's go ahead and find the slope, and that's the y value of the second point minus the y value of the first point, and now in that same order, the difference of the x values. And as you can see, we have a -9/3, and let me go ahead and do that here. -9/3, which is a -3. Okay. Let's do the same here. The slope is 2 minus 5 over -4 minus 1, and we have a -3 over -5, and we come up with 3/5. In number 15, kind of going out of order, we have 5 minus a -7 over 2 minus 2, and that's 12 over 0, and that slope is undefined. We cannot have 0 under, okay? We cannot have 0 in the denominator. Let's go ahead and try number 12. We have the slope equals 2 minus 4 over negative 4 minus 2, and that's a negative 2 over negative 6, and that's a slope of 1/3. Looking at number 14, if we subtract our y values, what do you see? We end up with 0 in the numerator, and 0 divided by anything is 0. So that slope is just equal to 0. Okay, let's look at number 16, and this is the last problem on this worksheet. And we have a stack of posters to advertise a production by the theater department. And actually those posters cost $19.95 plus $1.50 per poster at the printer. So we are asked to write a linear equation to compute the cost, C, of buying X posters. So X is equal to the number of posters. And we do have a fixed cost of $19.95, and we have a variable cost equal to $1.50. So with that, our cost function is going to be equal to that fixed cost of $19.95 plus $1.50 multiplied by the number of posters. So multiplied by X number of posters. So what you could see, we could go ahead and write this in slope-intercept form, 1.5x plus 1995. And that is the cost function. Again, we have a fixed cost and we have our variable cost. And it's because that cost varies depending on the number of posters. And that concludes this worksheet.